All right, everybody. It's Mr. Lamb coming to you, redoing these videos. These last few videos, I realized that the sound was not working. So here we are on President's Day, and we are going to try these videos one more time, see if we can't get some sound for them. This first video is with section 8.2, finding the length of sides of similar figures. And there's a question that's going to show up in the practice and in the mastery that's a little tricky because you have to be able to go back and use some of your Trig, your SOHCAHTOA stuff from units past. And I just want to make sure that I show you a problem that is similar to it that can help you kind of along your way. So in this problem, it asks for the value of n. So if I look at where n is located, right, n is down here, and n is this whole distance of this side. And it would be all well and good if on the first figure, on this small figure, if I knew the number down here. Because if I knew that number, then I could set up a ratio of 12 over 24 equals that number over n, and then I could cross multiply and solve it. But the unfortunate thing is I do not know that number. So really what I'm going to find is I'm going to find on the big figure where the number sign is, where that hashtag is. I'm going to find that side first, actually, because in order to do that, I can set up a ratio. So because these two things are similar, 12 is to 24 as 8 is to whatever that number is. So I'm going to find that number first. So I'm going to say 12 is to 24 as 8 is to, I'll call it x, all right, that missing number. All right, when I cross multiply, I have 12 times x is 12x, and 8 times 24, 8 times 24 is 192. And then I'm going to divide both sides by 12. And I'm going to find x to be divided by 12, 16. So that means, all right, this side over here is 16. Now, why is that important? Well, it's important because in order to find n, I'm actually going to do a little trick here. I am going to dotted. I'm going to drop a 90-degree line straight down. Now, this 90 degrees, that means I have a rectangle over here that has a side that is 24 on the bottom. All right, that is going from this left corner to where I dropped that 90 degrees down. And now I need to find this little distance over here. I'll call it m. I need to find the distance on that little section over there of that triangle. Well, with that being said, I'm going to actually take that triangle and I'm going to do my SOHCAHTOA to the triangle. If you remember, way back when we said if we knew an angle of a right triangle, that I could do trigonometry, I could do SOHCAHTOA. So if this is my angle, this side would be my opposite leg, 16 would be my hypotenuse, and m would be my adjacent leg. So since I'm using adjacent and hypotenuse, I would choose to do the cosine. So the cosine of the angle, 50, is equal to adjacent over hypotenuse. And the variable is up high, you multiply. So 16 times the cosine of 50 is equal to m. So let's put my calculator for that. Mode, make sure I'm in degrees. Here it is. and I have to do 16 times the cosine of 50. So that is 10.28 or 10.3. So m is about 10.3. Right, which means if I'm going up to my figure, right, this side right here, it's about 10.3. Now I can finally find n. So n is going to be found by taking 24 and 10.3 and adding them together in a little segment addition. So 24 plus 10.3, in this case, n is about 34.3. That is rounded to 1 decimal point. How will this problem look a little different for you? The sides are going to change, the angles are going to change, but the process is going to be exactly like this one. I don't know if it is sine, cosine, or tangent that you have to do in yours, but you will utilize that same process. The steps are going to be very similar. So I hope this helps with section 8.2, and best of luck.